Problem 22, we're going to be solving a rational equation by graphing. I left problem 21 at the top of the screen so that you could see another example of working with a rational equation by graphing. So here, the right-hand side, we have 4 plus 3 over x minus 4, which when you graph gives you this rational function graph here. The left-hand side is 5x, which is this linear equation right here. So you can see for this problem, we're going to have two intersections. For 22, it's going to be a little bit different. The right-hand side is going to look something like that rational part there. It could be in different locations. The left-hand side is going to be a horizontal line at 3. So let's see how that works. So 3 goes in for y1, 1 plus 3x divided by, and now I need to use parentheses, x minus 1. I have to be careful with my denominator. Then I'm going to press graph. So take a minute and transcribe that graph over in your space here, and then come back and check your work with the video. Okay, your graph is going to look something like this. Here's the line y equals 3. We have an intersection here, and that's up here on the calculator. I'm going to start by finding that, second calc 5, and my cursor is here. We have a vertical asymptote at x equals 1. If my cursor had been on the other side of that, either on this graph or on this graph, let me show you what would have happened. So if my cursor had started over here and I had gone through the intersection process, see how it says no sign change? It gives us an error. So I'm going to press enter because that's the same thing as quit. And then I'm going to go back to my second calc process, number 5, and I'm going to move that cursor across that vertical asymptote. I have to get closer to my intersection on the correct side of the vertical asymptote. There we go. Now let's hit enter 3 times. See how it gives me this intersection now? So watch out for that with these functions. The calculator does not work well across the vertical asymptote. So here we have an intersection at -2, 3. So that -2 value, x equals -2, is going to be our solution to this equation. We want to understand why there's no solution over here, and that's basically because you can see by the shape of the graph that there's a horizontal asymptote at y equals 3, so we're not going to cross, even though mine looks a little bit weird. If you look up here on the calculated graph, you can see that this graph is going to continue here and not cross that line or touch that line. So x equals -2 is our only solution to this problem. We also need to just make a mention of working with this problem, looking at the domain. The domain is going to be governed by this denominator right here. So we're going to have all real numbers, x not equal to 1 for our domain, which means that x equals -2 is a viable solution.